wise folks on the panel today, and I'm going to have them introduce themselves quickly. Super excited to have Ben Cox from H2O. Ben?
Hey everybody, my name is Ben Cox. I'm Director of Product Marketing at H2O. I help lead our responsible AI program here. So a lot of what I do is around research and product strategy and figuring out how we can build a better product ecosystem for responsible machine learning and help, author the appropriate thought leadership to kind of push the industry forward.
Raghu?
Hello everyone, my name is Raghu. I am part of Discover Financial Services Modeling Group. My day job involves developing models for fraud, collections, AML, and compliance teams. And my other part of the job includes, really the passion includes researching explainability and bias interpretability and measurement. So that's about me.
Welcome. Steve?
Hi, everyone. Steve Dickerson, also with Discover Financial Services. I'm the SVP of Decision Management and Chief Analytics Officer.
Welcome.
Happy to be
here. And the one and only, Agus.
Thank you. Agus Sudjianto. I'm the head of corporate model risk for Wells Fargo. So my job is overseeing all the models that we deploy at Wells Fargo.
We usually call Agus the Lord of all models at the
good ones and the bad ones.
So it's an incredible pleasure to have Discover come back for the second round in the series of Fairness in Lending panel. We co-hosted definitions of disparate income and adverse action reason codes. We had a lot of simple first session about a month ago. This one is a series that continues that to the next level of deep dive. We hope to continue this as the next one, probably in January. So stay tuned. Without further ado, I want to kick off about questions around fairness in lending. How does Discover do that? How does Wells Fargo do that? Let's get the basics out of the way.
Right. I'll kind of bridge us to the last kind of conversation. When we talk about fairness, certainly as a regulated bank, we talk about fairness in lending, which is highly regulated activity. And it really revolves around the adverse action reasons codes, which is if you turn somebody down for a credit action, you have to provide them a reason for that, right? So as the banks actually started moving into machine learning, really away from logistic, that was kind of a hurdle to figure out how to do explainability with machine learning, right? And that kind of pushed us into this discussion with Sri and Agus and others about making sure that there was a kind of a clear language that we're using and a body of language that we could kind of help develop with the regulators to have the conversation, and that was the considerations paper that's out there that we really spoke to last time. So I guess two kind of points off the off explainability is there's a lot of adjacency with explainability, right? Clearly we built out the explainability for adverse action reason codes, but once you have it, you really can think about other industries, but also within our industry, you can use it to develop hypotheses, right, that really can drive your test and learn strategies. Sorry, Agus, one more kind of point before somebody starts asking the questions. Certainly in the US, for federally regulated banks, all of the data we use has to be FCRA compliant for those decisions. So, when people start talking about alternative data, we really talk about alternative FCRA data. And I know that's not the case for the rest of the world, also in other industries, but I'll just put that out there at the beginning of the conversation.
So you can't use any data that you can get on the internet to do?
No, you can't scrape the internet and make credit decisions. we can't even talk about it, right? I mean, my compliance team is probably emailing me right now about even bringing it up. So,
Agus, do you want to comment on?
Yeah, I think Steve explained it very well. We are very, very deliberate and careful in terms of from the beginning, in terms of the data, what data you can use, what variable you can use. So very upfront in here is our legal and compliance partner involved in the decision upfront, what can and cannot be used as part of model building. And then model developer will do all the testing, independent model validation will do all the testing, and close the loop at the end. What's the finding from model validation, from independent model validation? If there are any concern, that's the discussion with the legal and compliance again, also at the end, before model are being released. Even post of that, every bank in the US has fair lending activity that use model to test model, and not only to test model, but also to test the final outcome or decision, because model are used along with other credit strategy and other things. So it's a very, very carefully done in the US for lending side. But this, when we start talking about fairness, it's also touch other area. That's not only lending. Yes, lending is very highly regulated, but non-lending as well, non-lending decision. It's very, very front and center for us as well in terms of fairness.
There's fairness in non-lending context as well.
Yeah, but if you think about it, all activities at a bank are around lending. So if somebody's calling in and you're doing something to them that prevents them from a potential offer, right? That can be seen as a fair lending problem.
I think that's very, very good question, and a very good comment from Steve, Sri. When somebody go online and get product offer, the product offer has to be fair, cannot be discriminatory in terms of demographics. So we have to make sure that the variable are used in the model will not become a demographic proxy in terms of decision. So it's very important. But in terms of something more mundane as well, when we look at the fairness as well, or bias or fairness, when we receive a lot of customer call, be it query or be it complaint, right? So we have voice to text. So if somebody speak with heavy accent like me, and the text tend to be, the voice to text translation tend to be missing, that can be a fairness issue as well, because some of the complaint or some of the concern may not be appropriately captured.
Thinking about bias, data bias and algorithmic bias are two common themes in this topic, and be interesting to. There's several Q&A questions that came up even during the run-up to this event. I'd love to have Raghu kick off on data bias and perhaps follow on algorithmic bias.
Thanks, Ray. So today my focus would be to kind of define in general what bias is, and how data bias and model bias and or algorithmic bias interact with each other, and then go on and talk about a little bit about fairness criterion as to how this data and algorithmic bias can be viewed, and then finally talk about how we can actually measure them a little bit. So when we talk about bias, first things first, bias has always existed in data. It's not a new, a phenomenon which has come in the recent times. It has always been there, even in the logistic days, or even in the machine learning world right now. Now that said, what happens in a multivariate or a machine learning setup is that sometimes the nonlinear forms can overfit in specific regions or with specific classes. which can further exacerbate or in some cases alleviate the data bias. This can be loosely thought as a model bias which follows the data bias which already exists in a predictor. So, digging one layer deep.
Raghu,
Yes.
if you could come closer to the.
Yeah. Sorry, my speaker system has been acting up today. So if you take a step back, actually, bias can be viewed as an ability to differentiate between two subpopulations at a level of the data or outcomes. If you really look at it, the predictors and response variables constitute all of the data. The differences in the distributions can be thought of as the data bias. The differences in the subpopulations which come out of f hat of x, which is really the trained model, can be looked at as the model bias. Now, with that in mind, if I were to talk about the way to classify or look at the fairness criterion, again, three basic components in any model. We have predictors, we have a target, which is also called label, and then we have a protected class, right? Let's say a binary protected class. With that setup, there are three papers which are really influenced, at least me individually and our team in coming up with a fairness criterion. The first one is by Feldman, who talks about statistical parity. What do we mean by statistical parity? Statistical parity is the given two groups. A classifier satisfies this definition if the proportion classified as, let's say, defaulters in this case, as the target, from one group is equal to the proportion of defaulters on the other group. So your target on both the sides of the protected class should be equal. That is the statistical parity. The other way of looking at it is that from Hart paper, H-A-R-D-T, and we can post these papers later on, right? Hart talks about equalized odds. And what do we mean by equalized odds? The amount of times for each classifier, each protected class binary attribute, how many times are you getting it right? The target variable, right? So the first way is statistical parity, where we look at, the two groups are classifying the target variable properly. The second one, Hart paper, looks at how many times we got that target actually correct based on the protected classes.
Agus, you want to, sorry to cut you off, Raghu, the audio is quite bad.
All right.
Agus, you want to chime in on algorithmic bias while at it, and we'll start posting these links as well in the chat session.
Well, we start with the data bias, of course, yeah, because that's what we have. But our algorithm can be biased as well. So after all, one thing is two things when we talk about algorithmic bias, because all the training is based on models, so people can argue whether data is biased or model is biased. But we know model training, it's involved of parameter estimation, right? It's parameter estimation. So we do from the get-go, you can have modeling techniques that train very differently. You put different weight, and all of those things. And for example, by nature, the ensemble learning, like gradient boosting and all those things, is basically putting weight on samples, right? So algorithm is it can be bias. It can come from algorithm as well. Deep learning, we talk about deep learning a lot. In it's depend on how you choose the hyperparameter, how you train it, and all of those things that you really need to study very carefully. And for that, explainability that Steve talked about is very important to diagnose, to really understand what the model does. So that's how you need to put attention a lot in the algorithmic bias as well.
So that I mean, taking a nonlinear stab there, no pun intended. From GBMs to GLMs to neural networks. I know you've some groundbreaking work on that, which you just almost recently announced. Are there thoughts on why regulators are gravitated towards GLMs and GBMs, and how can we start getting them into the fold of using machine learning, and how open they have been?
Yeah, I think it's I think there is a lack of understanding and misconception and all of those things as well. The area evolving very, very rapidly, right? GLM is very simple model. We know exactly what's the form is, so it's very explainable, very transparent, and we can measure it. And when the model make decision, we know exactly. And so traditionally it's been there for a while. People are comfortable, and the model structure is easy to understand. So then when we start using a more complicated stuff like GBM, then it's well, the tree is very simple. Most GBM is based on tree, a simple tree. So the tree is very simple, tree is very interpretable. But now when you use 1,000 tree, that basically is so now becoming more opaque and a lot more complicated, and you have to use a lot of post hoc analysis and things like that. So I'm a little bit biased here. We're talking about bias 3. Yeah, I don't like artificial flavor, so I like the natural flavor in the food, you know. So when you have model and you have to use artificial flavor to explain model, that's if we can, let's stay away from that, you know. Get the natural flavor that the model is very interpretable. I'm not against any of the post hoc explainability and things like that, but it's just, for me, it's artificial flavor. So this is part of it why I work a lot on the deep neural networks, because we can make deep neural network very interpretable without artificial flavor. So we just published brand new paper. So some of you that interested in, you can follow my LinkedIn, and we publish how to get explainability of deep neural networks without artificial flavor, right? You get exact explanation, just like GLM model.
Steve, what are you, not to put you on the spot with a controversial topic, what are your thoughts on post hoc explainability measures like LIME and SHAP that are becoming very commonly used? And I think Ben would have a comment on that as well.
You know, both kind of the topics. So there's kind of 3 things that we're talking about. We're talking about bias, we're talking about explainability, and then there's the connection back to, you know, having the conversation with the regulators. And I mean, these are great conversations, and this is really what we tried to start. It was really, I guess, a year ago with our considerations paper, and I think they just sent out the link, is with regulators. We as an industry, and that's, you know, with Agus here, it's important for us that, you know, we help the regulators have the same language as we do. So that way, when we're kind of going through our exams, which there are many, that, you know, we can already get over the first hurdle, which is making sure that we're all speaking the same language. And so that was really kind of the thought about building, you know, starting the original white paper, but also kind of continuing that paper with these events. So that, you know, the regulators are very open. They're trying to learn through this as well. You know, there's multiple regulators, and, you know, there's different divisions of each of the regulators. You know, and Agus knows them all. But you know, again, it's as a, you know, really as an industry, and when I say industry, I'm being inclusive of the regulators, because you don't have, the financial industry doesn't exist without the regulators. You know, we have to go on this journey together, to you know, because I think there is some social value in making better credit decisions, and, you know, and fairness, and reducing the amount of bias. And as far as the question about the post hoc explainability techniques. At some point, you have to do what you can, right? But I'm with Agus. You know, no artificial flavors here as well. But I really like that. And yeah, check out his paper.
H2O.
I'm a little jealous. I'm pushing our own paper, but you know, his is actually.
Well, you published very awesome paper on the fairness. Raghu share with me, Steve. Yeah, awesome. I think that's what I enjoy. You know, the interaction that we as industry, we are very open, right? We in it together. We try to share and to educate so that the broader acceptance of the methodology, and we can use methodology safely for the best to protect our customer. So I think that's very important.
And and we'll give it back to Shri. But you know, there's no shortcuts, right? I mean, you know, it's all about rigor, right? And thoughtfulness. And you know, kind of being very clear on you know how you're moving forward into your business with machine learning or AI.
A lot of practitioners in the audience. I was going to ask Agus. I remember asking Agus many years ago, and then of course the chance connection between Raghu and Steve and Agus is an incredible testament. The comment he made at the time, and I wanted to have the audience listen to that too, is what is the secret of getting machine learning models passed through a heavily regulated environment?
Sri, at the end of the day, it's really how, as a model developer or as a model, your model risk management, how strong is it? You know, how you understand basically is you have to be able to demonstrate that you manage all the risks in the model. You understand the risk, and you know how to manage it, and that's how you convince your regulators, right? So I think that's where the regulator have very all the best intention to protect customer. That's what they do, and that's very important job that they need to do to protect the customer and to protect the institution. So then for us is to demonstrate our ability to manage the risk, because when we using model, we are taking risks because all models are wrong. So if we know how wrong the model can be and how we manage it, that's all about risk management. So I think that's how the key is really be able to demonstrate that you understand the risk and able to manage the risk.
So I would add, I mean, just a couple. We have a very diverse audience here, so it's very exciting. But we're very much speaking to U.S. financial institutions, right? And the kind of the primary focus, certainly in the past, the regulators have evolved kind of include bias and fairness. Always important, more important now than they were. But the primary is safety and soundness. Right, because you have a large institution like Wells Fargo, you know, the health of the economy is really dependent upon, you know, the primary big banks and making sure they're not doing anything that would, you know, end up being Lehman Brothers, right? And so that really is kind of the purpose. But you know, kind of answering the question, you know, the first step is getting through your model risk management group, right? And Agus has the model risk management group, so. Certainly on the frontline side, you have to maintain the right level of rigor and relationship with the model risk management. Then you go through the model risk management, you get everything validated, and then the regulators come in and check your work. But it's a long process. I think it's a very robust process, and it really, again, having the long-term conversations around you know, around bias and fairness. And model performance is important to work with your regulators to move forward.
In terms of data, we would talk about that briefly while we got cut off. Alternative data sets. I want to touch on that topic. We have a lot of data providers in the audience as well as their other newer forms of data that's emerging every day. How can one be careful about bringing the right kind of inadvertently not introducing a proxy variable? What are the what measures do banks and regulators and regulated environments can take?
So, Raghu, you want to talk about the techniques? See if your mic is better. You're on mute.
You're on mute. Yeah.
Can you guys hear me now?
Yes.
Better.
All right. So sorry about all the confusion earlier. So talking about regular data or alternative data, it all boils down to how we measure bias, right? And that's where I think I got cut off. So once we have an idea of how we define a bias, this might differ based on each and every institution looking at what bias means for their data set. It boils down to how we measure bias. And for measuring bias, again, it boils down to what are some of the key metrics we are looking for, right? So like I was mentioning earlier, one of the things we want to measure is statistical parity, where let's say the focus is on looking at getting the target variable. Let's say the target variable is defaulters, correct on both the sides of the protected class, say ones and zeros. With that, a couple of metrics which we have found, in general theoretical sense. One is KS, where we look at how well the maximal statistical parity classifier bias can be looked at different thresholds. And the other one, just to plug in our paper also, we found the Wasserstein's metric, WASSERSTEIN metric, which we found pretty helpful in measuring bias. KS, has been used forever in measuring the performance of the model by looking at the maximum difference between between the two CDFs. Let's say the goods versus bads, however you wanna talk about it. But it looks at a difference at a point, right? The KS looks at a difference, max difference at 2 points. What Wasserstein's metric helps us do is look at the area between, very loosely again, defining it, area between the two CDFs, wherein you look at the overall measure of the bias across the two competing classes or two competing measurements. So coming back to your original question about alternative data or regular data, it's very important to be transparent in showcasing how we define bias, how we measure bias, and then provide confidence to make sure that we don't include any proxies, and working with the compliance team to ensure that there are no known proxies as well as unknown proxies coming in through these correlations within the data setup.
Thanks, Raghu. I also want to divert the topic to another interesting emergent explainability challenge, which is around NLP. How are you using explainability in natural language processing today?
Yeah, I think the complication on the NLP is really the use of the word embedding, right? So if we use back of word or any of those, the explainability is relatively easier. So when we start using word embedding, now we have things are messed up together, right? It's all, what is this word embedding really mean? So I think that's a challenge. So we wrote a paper on this. I think the key is we need to separate two things. One is the features need to be interpretable. In NLP, the features need to be interpretable. And then the model, taking this as an input features, how to explain what the model does, right? So the NLP problem is two things. The feature, how to create features that are interpretable, then how to create model that is interpretable. Now, and how to create feature that's interpretable if we use back of word or you be using the hot encoding, is very easy because word we can see this variable is associated to this word and so on and so forth. But modern machine learning no longer use one hot encoding anymore. Now they're using word embedding. So it's just like people that are familiar with statistics. When people do principal component from original variable, you create principal component. What your principal component really mean? That's almost means nothing anymore because that's exactly what happened with word embedding. So what we did, Sri showed it in the in our paper that we published in arXiv, is basically first is from the word embedding, you can use filter, convolutional neural network as a filter it, to come up with interpretable features. And then you run it to a model that's very interpretable as well. With that, then you can say, here's what the model does and what features are very, very important. So in NLP, like I said, you have to do two things. The features need to be interpretable, then the model need to be interpretable.
Some of our customers, and Steve, maybe you can speak to some of that experience, are worried about models that are embedded in some of these speech-to-text systems that are a little bit more black box, unlike H2O, which has more transparent open source models, or you can actually go look at what was really run. They're embedded inside a voice-to-text or a kind of a OCR document reading models. How are you kind of trying to kind of decode or at least look for model bias?
And so I mean, I'm like a one-hit wonder, right? See the paper, but no, it's actually really interesting. And for embeddedness analytically, Agus and Wells Fargo is ahead of us, right? So I'm learning about that as he's explaining it to you as well. The only thing that I would kind of add to that is there's a separate use of the word embedding, so we'll have to figure that out. And maybe next time we'll have a separate language for it. So when we talk about embedding, and especially with our regulators, we're talking about stock algorithms that are embedded in front-facing, consumer-facing operational systems, right? Like chatbots and things like that, right? So where we're actually using a third-party tool to actually run something, and there is some concern about being able to explain how those work as they're embedded in these products that we're buying off the shelf. So that's kind of where we are on that journey. We kind of recognize it, and we're kind of moving forward from there. Again, Agus would be the expert on the call right now when it comes to the NLP.
It's on the machine learning that embedded in the application that we use. That's a tough one, Sri. Yeah. So we apply the same rigor in terms of model risk management. Our model validator tests those independently as well. Sometime, and the degree of testing, if it's particularly as a vendor solution, degree of testing and degree of transparency will vary. Of course, we cannot expect the transparency that we get from internally developed model compared to all those that embedded in the application. So we do various ways to do testing, from very, very simple in terms of sensitivity analysis testing to be able to explain input and output, do some kind of adversarial testing with counterfactual kind of example, right? So that's something that we can do. And when allowed, because in some situation not allowed, depending on how the agreement with the vendor to do a benchmarking, right? Because sometimes in the agreement it's a little bit tough because it may be seen as a reverse engineering, when in part of the contract you cannot do reverse engineering, right? So then you cannot do like, okay, this is the input, this is the output. Let me try to understand what inner working around it by building a parallel model as a benchmark, as a comparison. But again, that's depend on model to model and the agreement with the vendor.
Yeah, on that topic, I think we're doing a lot of back testing as well as adversarial kind of testing around the models. Pre-trained models have inherent bias based on the data that it was trained on. And so having a good, there's no escape from having a very good validation benchmarking environment.
And I think that's probably the biggest, especially in the NLP world, is probably the biggest barrier to do all this one-shot learning, transfer learning, and anything, right? Because how are you going to validate those? And we know language is by nature is bias. Language as representation of demographics. The style of writing is gender bias. So those kind of things that we have to grapple outside lending.
Yeah, especially to look for monotonicity in, for example, sentiment analysis or some of these, you don't see them linearly change. Right? And the quip I had about your artificially flavored methods was we think the word artificial applied to AI itself is actually a misnomer that has like almost plagued our favorite space. It is intelligence, and we need to kind of start treating intelligence the way we would treat others. Test it, validate it, trust and verify and trust again. Model robustness. I want to tweak, it's a small tangent since you brought up adversarial testing, and it's a question for all of you on the floor. How should one think about if intelligent people have blind spots, intelligent models also have blind spots, how should one cover for them? And second, how should one expose them? And so that our machine learning models don't have a key blind spot that then gets exposed by either fraudsters or even credit testing.
Before I answer that, I probably want to toss it to Steve or Raghu, because in terms of model robustness is long-term practice in the credit scoring, right? You guys monitor the population drift and etc., right, to do that. So I'll toss it to Steve or Raghu first, and then I'll talk about the adversarial testing.
And I'll let Raghu kind of answer. I was gonna say I think intelligence in AI is actually probably the wrong misnomer, because I think that kind of I bring that up because it's part of the answer to the question is that I mean, these are very simple things that are using historical performance to predict future performance, right? And true intelligence is about thinking about other things that can happen, right? Structural changes in the data, predicting COVID, whatever it has, I mean, those are all the things that, really would bring intelligence to the system. But I think adversarial learning is actually kind of a step towards that. And I'll let Raghu kind of talk about what we're doing.
It's a great point.
Yeah, so thanks for the setup, Steve. I think that's perfect for the application we are looking at or will be looking at soon is, what are adversarial models? Adversarial models really help us, create our own data, which could very well be used in looking at some of the fallacies or blind spots, like Steve was saying, of the champion model. That's one way of looking at it. The other way of looking at it could be, there could be some black swan events coming in the future, just like the last 7 to 8 months have been. You don't know how the next 12 months data could look like. So the business could make intelligent decisions, intelligent scenario analysis based on, let's say, the pricing can change like this, the utilization can change X way, Y way, whatnot, right? So the power of the adversarial model setup is two-form. One is to look at the fallacies of the champion model and which correlates to the robustness to say, in this particular scenario, maybe the model might not work, right? And similarly, also give a good segue into the future. If the future is changing, if the customer behavior might change, how would this model how would this model predict if the predictors themselves are changing in particular way? So those two become the core. Agus, Steve, want to add something?
Yeah, I probably want to put a little bit something complementary to that, and I don't mean to disagree with other people and things. The obsession of people to model performance at the detriment of model robustness. So I think that's very, very important, because especially in the era of Kaggle competition and auto ML, yeah, people want to get the best model that have the best performance. Yes, but that's assume your data is static. I have a split of training data and testing data, and I pick a model that is best on the testing data by applying all kind of hyperparameter tuning to do the auto ML feature selection, and the third digit will make you bump you up into the Kaggle ranking. So that's something that we have to be more balanced, be careful. As a responsible model developer, when you put model into production, will change, your data drift. So model that has the best performance based on your training and testing data may not be the best model in production, because the world changed. When I was in automotive industry, I led engine design. So when we design engine, we test engine in the hot place in Nevada or in Miami, but in high latitude place in Colorado. We test it in northern part of Canada that is very, very cold, right? The product's still functioning and functioning properly. When we build a credit model need to be stable. In the environment changes, the models still have to be good. We cannot do it like marketing model that is you retrain it all the time. Credit is not marketing. So it depends on the in the situation here when we're talking about model robustness. Don't be obsessed with the performance. And this is something that I want to talk about. We measure something that very, very complicated like machine learning with a single measure. AUC, I just pick one. AUC as a single measure to measure complicated stuff like machine learning. AUC is a measure for the old way, a single regression, we measure it with AUC. That's perfect. But in deep learning, you have 1,000, 1,000,000 equation, and you measure it with single number, AUC, and not only single number on the AUC, the third digit of AUC. To me, that's insane. So that's what people need to do. Think about how you test your model when you have your data change. So you understand if I perturb the data, what the decision is going to flip. That's very, very important thing, so that you have a very, very stable model that is robust against environmental changes. But it really depends on the application. The other aspect that the talk about adversarial, sometimes a model operate in the adversarial environment. Your fraud model, the fraudster trying to circumvent your model. Our model that monitor people conduct and behavior, people have incentive to circumvent the model. So you have to really test the model for robustness, how the model will be fooled or can be easily fooled.
No, I completely agree. Robustness is far more important than performance certainly during the development. And I just wanted to add a couple things. I mean, that's where we need to be thoughtful and also have the domain expertise, because if the actions of the fraudster is changing your data, then you need to stay ahead of that. And again, the data structures of marketing are different because, if one of our competitors starts spending a lot of money that they hadn't prior, I mean, the whole framework of the data that you're making the predictions on are changing, right? Credit tends to be a little stable, but also far more important, back to the safety and soundness conversation. And I can't help but kind of thinking about, when you're doing this, think about border conditions when you're trying to do optimizations, right? And if anybody's, graduate work in microeconomics, the first thing you have to do is check for border conditions, because the professor is trying to trick you to find an interior solution that doesn't exist, right? And so if you don't check the border conditions, you're not going to finish the test. And so that's kind of the same thing here, is that, you might have in your testing sample a very good prediction, but how far off does the data have to move before it fails completely? And that Agus is kind of, I really like the example of the Ford Motor Company and testing the cars, because I used to have a 1976 Saab that, they did not test it in the heat of Arizona. We had a lot of problems during summer days in Phoenix, where I grew up. So, but come on, a Swedish engineer, how would they even think about, oh well, we need to take it to Death Valley to test it, right? Nobody would ever live in one of those places, right?
I think that's actually, and this is an audience question on the topic, and weave into that. But that's actually what is the premise behind our upcoming work, creating environments that automatically, like, rigorously try to induce the min-max. Agus likes to say, what is the minimum amount of perturbation in the data you can do to maximize the error in the AUC?
Yeah.
So this automatically, for every model that's created, back test it. Why was all models are wrong? Some models are useful. So when they're wrong, why are they wrong? And try to understand, explain the delta where it's happening, or detecting drift. And
I'll let Agus handle this, but I just cringe at the word automatic. Right? Because you can. I think building synthetic data and building systems that produce synthetic data for this kind of testing is fantastic. But the level of intelligence, again, that is going to have to go in building those systems so you can do it automatically. I think that's I cringe. I think about screen scraping in the blue screen days, right?
I think it's very important, Steve, because when we say we want to perturb the data, it need to perturb into things that make sense, the most make sense way, right? From the business point of view. So Street is in the business of making tool, right? So how to create tool that will facilitate the user to be able to do that testing. So when I said, when we look at the automation, it's really how can we provide a vehicle that people can just need to worry about the steering and the braking, not to have to worry about looking under the hood, right? So I think that's what's important on this, is how to provide vehicle, how to provide things that easy for the user to operate, instead of let it operate, and we can talk about this, and I'm very passionate about this. When are you going to let your deep learning to drive your self-driving car? We can debate about that.
I would pull it back to the data generating process, right? It's as long as nothing outside of the parameters of the self-driving happens, you're probably good with self-driving. Right? It's kind of like airlines, right? It's just like, if something goes wrong, well, you want a Navy pilot up there, a retired Navy pilot. But every day they fly themselves. But the second you need to land in the whatever the New York, the river, the Hudson, you want somebody that actually has the talent to do
right. And this is that's the issue of model safety, right? Because we know model will fail or will create unintended consequence. And I have my nightmare a long time ago in my first career when I was designing car engine. We have the 5 throttle body freezing in the cold winter in North Canada. We produce millions of engines. 5 failure is unacceptable. That is what happened in that. So I guess it's depend on the mission critical that we have here on how we use the model, and understanding how the model will be wrong so that we can create a model safety is very, very important in my view.
One thing we found in this is as a good, during COVID, of course, it's almost like a once in a lifetime event. Simple models were far more effective in understanding what's happening with the data, right? Can you touch on the topic of interpretability as an aspect of not just after the model has been built, but even while you're starting with the data, the transformations you're using, the algorithm that you're picking, to kind of the, how is explainability and interpretability, how can one take it as an end-to-end part of model development, not just now that I have a model, what do I do with interpreting it, its decision?
Sure, you can jump in on this one. So I think, as a software company, H2O, we built a toolkit for post-hoc explanation, but it's a much bigger question, and it's how can we build an ecosystem for data scientists to continually make intelligent choices with respect to simplicity, accuracy trade-offs, explainability, accuracy trade-offs. And I know that one of the things we talk about a lot is in the universe of models that you can create across a very tight band of accuracy, if you can lean towards more simple linear models or monotonicity constrained models, you should do that, right? And I think as we start to define this process and build software around it, the universe of decisions that you can make that are like in the explainability space gets wider, right? So I think it starts from, experiment design and deciding that fairness is a core secondary metric, but also leaning into the interpretable, understandable model methods that hold up better in uncertain scenarios, but also under scrutiny better.
Agus.
I don't want to dominate the conversation here, so maybe Steve first, then I can talk. Steve, you want to say, because I have a somewhat, I think there are two very broad spectrum, from sophisticated, complicated model and very, very simple model, and each have its own area how how we apply it appropriately. And I am at the camp of that model doesn't have, we don't have to sacrifice for simplicity to get the performance, and there is a way. And one thing that I decided to release a paper last night on the deep neural network explainability is exactly for that. You can start with complicated model, give the tool to diagnose itself to see how many, if you want how many linear model that you need for these complicated things. And I today a lot of things, a lot of hype on the deep neural network. It's wonderful tool, but when you, and also the application of Raghu deep neural network, a lot of success in natural language processing or image. At the end of the day, if you read the paper that I just released, deep neural network is no more than segmented regression. So all the intelligence that we talk about today in the deep neural network is segmented regression. So sorry to say that, but it's segmented regression in steroid. It's very, very clever how to partition the data. Once you partition the data, the final decision that Deep Raghu doing is linear model locally. So when you train neural network, you train Raghu neural network, you train the model to partition the data so that local linear model is the best. And the problem is in deep learning, you have 1,000 and probably 1 million of linear equation. And by the way, most of those linear equations are unnecessary. In fact, it makes the model less reliable. So in the paper that we put is how to simplify that, how to identify the linear model that extracted by deep learning that really useful and simplify it to that. And it's interesting to say this because we put purposefully one example in there, the FICO HELOC data that was analyzed, and Cynthia Rudin from Duke won the competition a while back. You run deep learning in that, regardless how big the deep learning is, apply the tool, identify all the local linear models in there, it end up with a single logistic regression is the winner, is the best model. So you can start with complicated model. You don't have to sacrifice with the use of complicated model, but use it intelligently, so that you come up with something that no more than what you need. So no fat, okay, lean model. They all you have, and we made the best performance.
Yeah, and you know, again, read the paper. It's very interesting and breaking news. I would just add that, you know, so you got to be careful about complexity because of domain, right? So you need to get out of the lab. You know, if you're doing collections modeling, you need to understand what the collectors are doing because you're trying to model their behavior. And if you don't understand what their behavior is, then then you're going to be wrong. You're going to be wrong every time. So I did watch, you know, a video thing with Bill Groves from Walgreens, and he uses the I think it's Johnny Cash's walk the line, right? So if you're trying to understand how to model something, you know, walk the line, understand what you're actually trying to model rather than stay in the lab and do fancy math. And that's kind of the last point on that. I know we're running out of a little time. I'm very much a simple guy, right? And the example I always use is rice. I mean, you know, everybody cooks rice, but it is hard to cook correctly. And it's 2 damn ingredients, right? It's water and rice, right? And so, you know, you don't have to get too much more complicated than that and have lots of failures. But
I caught
I'll give it back to you, Sri.
I caught Steve one day making his own cornbread. So he's he believes in building it from the elements, right? So that's really quite cool. Raghu?
Yeah, so you know, I'm part of the development team of the models. I actually couldn't agree more with Agus and Steve. You know, there is a lot of hype behind all these algorithms, but at the end of the day, when I go talk to my business partner, they're interested in how much lift I'm going to provide them, right? And more often than not, when you are in the domain, collections, fraud, underwriting, whatnot, if there is a complex algorithm providing a lot of lift, that is a good sign to really look deeper if it is really isolating certain or certain regions or overfitting in certain areas, right? And then work backwards. So having a, you know, using Steve's simple mind to look at why the algorithm is capturing incremental behavior than some of the traditional benchmark models would be probably a good thing as a gut check to say, how do we justify all of these explanations? So that's my take on this.
We have about 2 minutes left. A couple of questions that were interesting. Someone wanted cars to be tested against moose collisions, as they probably do for Volvos. How do you?
We did more than that. We do crash tests, right? So more than mule, you crash it to the steel barrier.
There's a question on address bias in small business lending. And I think that could be an interesting topic to end on, Agus or Steve.
You know, I think it comes back to again bias. You know, I'll even step back further. All of these terms, AI, machine learning, and bias, all need to be defined properly, right? So, when anyway, running out of time, but as an econometrician by training, when I think about bias, I think about the target variable, the expected value of the target variable not being equal to the target variable, right? I mean, it has a very simple econometrics definition, but when you think about small lending business and bias, you gotta go to the second or third depth of defining what you're actually asking, right? And then try to figure out how to measure it, right? And then make sure that as you're developing models for it or developing processes for it, because small business is very much a hands-on business, that you're controlling for those things.
Agus, do you want to end on what are the couple of biggest challenges for banks as they are going into the thickened crisis in COVID? So,
well, the biggest is all model. What we learn is all model are wrong, and it can be very wrong. So, and that's becoming a lot more complex. I think when we're looking at the hindsight, we talk about model robustness. Raghu talk about scenario testing. This scenario is way, way beyond the scenario that we ever thought about, right? So that's things. But not only that the model is exposed to something that outside its boundary, right? The unemployment outside the boundary, but worse yet, the regulation also impacting the model. Steve is in the middle of this, right? Because during the crisis, the FICO score going up instead of going down. People not paying yet, the FICO score going up. So the input, the things that coming to your model, the data that coming your model, also not trustworthy. So how do you deal with that? So at the end of the day, we know how the model will be wrong, how this data, we really understand with all the experience, and we know how to mitigate this. So that's the thing that we do.
That's a really good note. And again, I would just pull it back. It's the data generating process. Your data generating process just changed, right? So you better understand how, why, and what the effect of your models are.
Raghu, final words?
Yeah, I mean, bottom line, data is the king, good way or the other way. So, a keen eye from a data science perspective would be, what is it that is providing the juice in the model, and whether those attributes are, sane or on hypersteroids based on these algorithms. That looking at that and having that as part of our measurement is the key, I guess.
Ben?
Yeah, I think, use a little bit of common sense is a great point, but I would also say, embrace the rigor of this, right? Unpacking models is complicated. So lean towards softwares and tools that kind of allow you to control that ecosystem of decisions to make more responsible decisions with each step in like the data science lifecycle, right? I think that's a great place to start.
One of our favorite customers said that it's just as much about data sense, not just data science. Getting but
like that.
Wonderful panel. This could go on for a few hours, but we'd love to kind of let people go back to what we're doing. But hopefully we can see most of you, all of you, at the next session, where we're going to dig in further into fairness and explainability and model robustness, model distillation, some incredible topics that we touched today. And looking forward to hearing from audience on more question and answers. We weaved the Q&A based on your questions you submitted early on. And would love to kind of hear more as we do the next edition of explainability and fairness in lending. Thank you very much, Raghu, Steve, Ben, and Agus.
Thank you.
Thank you, Sri.
Have a good one.
Thanks again.